Good afternoon, friends. Welcome to the STP training webinar, which is Compliance and Agility, how it can be done. Our speaker for the day is Aprajita Mathur, and I'm Smita Mishra, a professional tester myself, and I'm excited to host you all and Aprajita on our STP webinars. Quick information for all of you, the next upcoming conference we have is Fall 2018 STPCon, which will be held at Arlington, Virginia from October 22nd to 25th this year. So the complete program is up for you for review and selection at stpcon.com. There are going to be workshops, sessions, keynotes, and a lot of networking involved. The discounted hotel room rates for STP attendees will get expired on 28th of September, which is this Friday. So please ensure you book your room by then to avail the special rates. And we absolutely love when you guys come back to our conference again and again, and when you come with your teams. So we have our special discounts for our alumni and team attendees that gives you huge savings. Please ask for these. Do reach out to us should you need any help on the registrations. You can email your queries to info@softwaretestpro.com. And the quick piece of information again that I have for you is that we have an upcoming webinar, The Art and Science of Test Automation by Mandana Nabizadeh on 10th of October. Mandana is the principal test automation engineer at Discount Tire Company. The link is up for you to review and register. Please go for it. And in case you are on Twitter, please feel free to share the conference information and about this webinar with your followers, connections. You can also add STP's Twitter handle to your tweets, which is @SoftwareTestPro. You can add the hashtag STP webinar, and you can also note down the speaker's Twitter handle. All right, let's begin today our webinar. A very warm welcome, Aprajita. We are very thrilled to have you here with us. And let me quickly introduce you for all of us here. Aprajita Mathur is a bioinformatics software quality assurance manager with an engineering background in bioinformatics. She has more than 10 years of software testing experience and over 5 years of testing in a compliance environment. She has worked as a functional tester and an automation tester on a wide range of products like instrument software, LIMS, web applications, and integrated solutions, which are used in the fields of agriculture, transplant genomics, forensics, and oncology. Currently, she leads the bioinformatics software quality assurance team at Guardant Health, which builds the world's leading comprehensive liquid biopsy. This non-invasive tool for accessing and sequencing tumor DNA is used by thousands of oncologists to help tens of thousands of advanced cancer patients. Wow, that's some meaningful work, Aprajita. With all due respect to the buzzing worlds of retail and media, I see your work as a high impact for humans, so thank you for all you're doing. And let me now transfer the control to you. Very warm welcome again, and the floor is all yours now.
Thank you so much for the warm welcome. I'm very excited to share this topic with everybody who has joined us, and I appreciate everybody taking the time from their busy schedule to listen about this topic. It's a very interesting space to be when you're working in a compliance environment and you are trying to be agile. And I will be speaking very much around software development in Agile, but also from a product standpoint. For today, we will go through a couple of things. I will talk about the project at hand, which I'm using as the use case for this presentation, what it was, what we did, the landscape, which is basically what was the business at the time, what were the compliance and that we needed to meet, agile butts, as I call them, are agile practices that we were following, but they were not really agile. What we uncovered during this product development, what we improved, what we had to further improve to truly meet that lean team formation and deliver on our final product. And out of everything that we tried and did, what really worked for us. So I will go through all of these in today's presentation. To start with, So started working on this project a couple of years back. It's already now in the market, but back in the day, it was just a concept or a thought. And this was back at Illumina. Illumina is a next generation sequencing global leader company in the field of genomics. And if you have heard of the term DNA or sequencing, Illumina is the leading provider in that service. So this project started at Illumina. It was around bringing next generation sequencing into the field of forensics. And this may come as a surprise to a lot of people, because when we talk about crime scene investigations and forensics, we are like, well, aren't we already doing DNA analysis? Yes, we are. But the DNA analysis done generally in the field of forensics is not next generation sequencing. It's a different type of DNA analysis, and I will go through that a little bit. My introduction to forensics was this TV series called Bones. I still love this TV series. It's about two people solving crimes based on when they find bones or human remains, and they link it to a suspect. After starting working in the field of forensics and on this project specifically, my dreams were really shattered. And I came to know about what's called the CSI effect. So when I started, I thought that every case in this world has, if it has DNA evidence, uh, you can wrap that case up. You would find something to link it back to the suspect, or even the victim, even to identify the victim. These tests are super fast. We can get these results in a couple of hours or minutes. Criminals will always make mistakes. And the most commonly seen things, especially on television, is that all of these forensic labs have high technology, and fast evolving science at their disposal. They have unlimited resources, and so they're able to solve all these crimes in like 24 hours, 48 hours. That's not really the case. And I I gave a small example of this screen from the series Bones. It's called the Angulator, where they're able to come up with a 3D prediction of the victims, how they look, basically. In all honesty, that doesn't really exist. Our science doesn't allow us to do all these things as I speak. So 5 or 6 years back in the days, we were working on this project. We were trying to see how next generation sequencing can be brought into the field of forensics to help solve some of these cases. In reality, only 30% of the cases have enough evidence to be linked to somebody, and only 5 to 10% of the cases have enough DNA. So they might have DNA, but they may not have enough DNA to actually solve the crime. And a lot of times it takes weeks and months to solve these cases. And we all hear about cold cases, cases which have never been solved. So we have all these problems in the field, and that is what we were trying to solve. A very quick description of how forensic really works. So every human has 22 pairs of chromosomes. So you get one from your dad, one from your mom, and then you have sex chromosomes, which basically decide your gender. And in the United States, FBI uses, as I point, 13 specific sites on the DNA, which are used for analysis purposes. These specific sites within our chromosome, I will go a little further, have very specific type of sequence, and these sequences are basically composed of 4 letters, A, T, G, and C. They occur in a very specific pattern that we already know about, and so every individual, if we have enough DNA from them, when we sequence them, they have some sort of unique signature between these 13 positions on their DNA, and you can very specifically tell who that DNA is from. So a very simple example, and this is a very simple use case. Imagine we sequenced somebody. These are the positions that, as you see, STR locus column, these are the positions that got sequenced. This is the data that we found in them. And as you can see, between the evidence sample and the suspect sample, pretty much everything matches except, let me see, one of these data points, maybe they don't match. But that tells us that there's a high probability that the evidence matches with the suspect. Now, this is a good use case. This is as in testers' world, this is a happy flow use case where everything is perfect. That's not the real life situation, right? What really happens is a very complex scenario where you would have degraded DNA. So if you were to find remains which have been in the field for a very long period of time, or if it's a mass disaster, if it's a missing person case, all of these cases generally would have degraded DNA. So you would not be able to get all of those 13 points in their DNA sequenced correctly, or you would only be able to sequence some part of that DNA, not all of it. Uh, Also, in situations, a lot of the cases have mixtures. What that means is you have multiple DNA at the site. So imagine a crime that was, happened at somebody's house. Now that house has a lot of people coming in and going, so it gets really difficult to differentiate between who was at the crime scene, who was not at the crime scene, who really committed the crime. All of these things start coming into play. And so these are some examples where the current forensic technologies don't really help. The current forensic technologies are called capillary electrophoresis, or more commonly known as CE. So we started to build out a product which would allow forensic labs to not only look at those 13 loci, but basically over 200 markers. This is a lot of processing power for them. But what it also allows you to do is take degraded samples and take mixture samples and analyze them at a level where you are able to differentiate between these complex data sets. The software itself, the product that we were building, went from all the way from taking the DNA, preparing it, running it through a sequencing instrument, and then finally doing data analysis to produce the results. This is a snapshot from the actual software. So this product itself had many components and many teams working on it simultaneously. We had somebody from the chemistry department working on it. We had somebody from the instrumentation side working on it. We had somebody from algorithms working on it. We also had a complete software team that was working on the software product. The nice thing about this product was that it was a completely integrated system, so the customer really didn't have to worry about anything. They would prepare their DNA, they would run it through analysis, and they would get the results. They didn't have to worry about any intermediate work between completing the DNA sequencing and then seeing the result. They didn't have to do any processing. Everything would be done for them. And so this allowed for like seamless integration between the system. The software itself also allowed for sample comparison techniques. So if you have two samples, say for example, you could compare them using the software and get an estimate and see how closely they match. You could do analysis on a bigger data set, which allows you to look at larger populations. So if you really don't know who you're looking for, then you could analyze it from a population standpoint. It also allowed you to do some phenotypic and ancestry prediction. So what that means, phenotypic basically means the physical look of a person. So eye color, hair color, stuff like that. We were able to predict that. We were also doing some ancestry prediction, basically lineage prediction, and many other features that this technology had. So one cool thing to see here, as you can see in this case, in this particular position on the genome, as you see, with the current technology, all you would get was that at this position, but this person has an 11 and a 12, versus with the new software, now they're able to actually look at the physical sequence of 11 and 12, and they could actually even see the differences. So see, like within 12, you can see that there's a very small mutation in the genome where a C went from C to an A, which can be very meaningful when you're looking at complex data. So these small, tiny differences in the DNA can make a big impact. This was not available before. Can you guys still hear me?
Yes.
Okay, sorry. Okay, so a quick recap and some recent news around how next generation sequencing is being used. So identical twins is a very good example for this. Identical twins, their DNAs are very similar, so it's really difficult to, if you don't have enough DNA evidence, it's very difficult to say which twin committed the crime. Uh, with the example that I showed you guys before, it's easy to identify these individual changes between these two identical twins and really pinpoint who actually did it. Another example that I would like to share is Golden State Killer. So this was a person who committed a lot of crime almost 30 years back, and he was never caught. And this was in California, multiple crimes. As you can see, I put out the information, like this is 1986, right? And he was recently caught using Ancestry Predict. This was not you. Our tool was not used to do this. This is just in the field of forensics in general. Somebody went and started looking through Ancestry sites, and they were able to link this person with another person almost 4 generation ups using next generation sequencing results. So this is the difference that this product can make in the world. So as we start, given the background of the product that we were trying to build, at Illumina at the time, or even today for that fact, um, compliance comes into picture when you actually start developing the product. So every product goes through a certain phases of life. You have an idea, somebody has an idea, you start working on that idea, and you try and do some research and development around that idea. Once you have enough data to back up what you are proposing to build, and the business is able to support that need, you get into your development phase, right? And so when we started on this project in the concept phase, when we were just trying to understand the market, when we started doing R&D, we really had no rules and bounds around compliance. We didn't really have to think about, oh, what is the amount of documentation we have to do? We didn't have to think about what are the regulatory bodies out there that we have to be compliant to. We didn't have to think about what are the compliance aspects within Illumina that we have to meet. We didn't have to think about any of that in R&D. What we also didn't have to think about was productionizing that product. So imagine you're working in a lab with with just 2 or 3 samples, and you have a small piece of software that's kind of hacking its way around doing data analysis. And now you are taking this small piece of lab equipment and software and putting it into production. It's never going to work, right? That's a tester's nightmare in some sense. It's not going to work. And you're going to have to improve it and optimize it to a large extent. And I consider all of these factors as part of compliance, to really look at all of these things together, right? So when we started, once we were done with our R&D phase, that is when we really started thinking about compliance. We didn't think about compliance before that. So even though the forensic project that we build is not an FDA regulated product, and FDA doesn't govern that within the US, there's a different body that governs it. But for the sake and purposes of this presentation, I would be talking back and forth around FDA. And the reason to pick FDA is because they are one of the most stringent regulatory bodies to comply with. There are many other compliant bodies, and I'm sure within the audience you work with different compliance bodies, but I will just take them as an example. So to start, every product has some user needs, which is what I was talking about in R&D phase, and you have some core where you start, and it's easy peasy to do that part because that is the starting point, that's the evolution point. That's when you start getting into your design inputs. You have a design process, you have design outputs, you have to do your testing, you have to do your validation, and at each of these steps you have to do review. And Waterfall is the perfect fit for this, and it works fine in small environments, in small projects, when it's very easy to define your scope when you know exactly what your requirements are, exactly how you're going to design it, implement it, test it. All of this worked perfectly for us. The waterfall model works perfectly in an R&D situation or in a very small lab situation, because you have a certain idea and you know exactly what the idea is, you know your hypothesis, you know exactly how you're going to test it. Everything works out fine. However, now you get into the real world, and now this is when we had to debate between what are we going to do. We had a lot of unknowns going from R&D to development. We didn't really know what this product is going to look like. We didn't really know what we are finally going to ship to the customer. We didn't really even have all the features, uh, all the features that went to the product were not known to us at the start of development. And that was one of the biggest reasons that we decided to go agile. It also allowed us to do iterative development. So what that really meant for the software team in particular was we thought that we will be able to address issues for our internal customers. As I mentioned, that this forensic group had multiple teams working on it, more than 5 or 6 sub teams, and each sub team had about 6 to 7 people. So it really and software kind of sat at the heart of all of this. So it really allowed us to address to all of these internal stakeholders as we went through, right? It allowed for better team collaboration, visibility into development, and it was a cool thing to do. Agile is the thing that everybody's doing, so that why not? Let's try it. So we started doing agile development, and these were some of the things when we started into our development phase. I have this big elephant because this is really what my team looked like at the time. Now that I look back, uh, we thought compliance is constant. We thought we had a nice package of things that we need to deliver, and it's going to stay constant for the software team when we have the finished product. We had processes and procedures in place within the company which we had to follow. We also uh, we also thought that we did agile development. So all of us thought that we are already doing agile development. We got this figured out. We have a backlog. We are grooming our backlog. We have a sprint board. We are doing our sprints. Everybody knows what they're doing. We got this. Then we realized that, but we also had phase exits. What that meant was within our, while we were sprinting, we would have to go back to senior management and say, hey, by the way, for the last 6 weeks, this is the work that we have done, and this is this is a gate exit within the company that we have to respond to, right? So we go back and it's like, oh, this is the work we have done, it's looking good, we're still making good progress, let's move forward. Where did that come from? I didn't hear of that. I didn't hear anybody in Scrum training telling me about a phase exit. I didn't know we had to do that. We also had multiple stakeholders. So all these people within the company, they had some aspect linked in the software, some need that they had in the software. So we were getting all these requests from all these stakeholders from all over the place. And because these are all individual teams, they would not know what the priority of the other team is. Everybody thought that their priority is the most important priority. So say, for example, the chemistry team came back and said, hey, I really need you to add this button on page A. And the algorithms team said, forget about the button. I really need you to build this database, like right now. I really need it. Now we have two different teams telling us two different things. We want to do both. Both of them are crucial. Both of them are needed for the product. But how do we get it done? And the biggest problem among all these problems was my agile is the agile. So everybody on the software team thought they knew how to do agile development. They knew, they thought the way they had done it in their previous company is going to work. They thought how they did it last project within Illumina is going to work. That was not the case. We had to really think about it holistically. We really had to think about this big elephant that was in the room. It was not just the trunk, not just the teeth or the tail. We had to think about it holistically. So after a couple of sprints, we started to recognize all these problems, and we finally came around and acknowledged that there is an elephant in the room. Once we did that, Within our sprint planning, we started to add artifacts that we require to produce for business level. So anybody on the software team, if they needed to make a presentation which is going to take a day's worth of time, we will put it on our backlog. We started to estimate, track, and account for all of these activities that were needed to be compliant in some sense, not just from regulatory standpoint, but also from business standpoint. We also started to account for internal timelines. So now if I had to build that database and I hadn't really planned for it from software development perspective, I had to now keep that into account within my sprint planning. We assigned one single person as point of contact. So one person within the software team was now responsible for all these multiple requests that are coming for different stakeholders. We had one scrum master. This role actually rotated between team members. And then we had one product owner. So our marketing lead at the time was our product owner. This person had worked in the forensics lab. She knew exactly how things were done in the lab. She knew where the product was going. She was interacting with external customers more than anybody else. So she was the product owner for us. And the most important thing that we did as part of acknowledging the elephant was getting trained. So we decided to use Scrum as our agile methodology, and all of us got trained in it. That was one of the biggest and the most important things that this team did, and I think that was extremely useful for the success of the project. The second thing that we did after doing all this was pre-work and alignment. So before our sprint planning, we would go and really start thinking about the feature that the software team was building, not from a software perspective, but really from the customer perspective. What is that the customer is going to do with this product? We set a goal. We set goals for the sprint, and these goals would basically would be something like, say, for example, build the database in the sprint would be the goal. So if we had other items in the sprint, other tasks that somebody had to do, they would not gate the sprint being done or not. Only that goal would gate the sprint being done. We had an acceptance criteria for the sprint. So every story that came into the sprint had to meet a certain criteria. And I will explain this a little bit because this is really important from compliance perspective. So imagine that you are building a product, and so I'll take the same example. You are building a database, and you are building one table in the database. Now, in order to build that table, you will need to understand the data structure that's going to go into the table. You need to understand what are the primary key and foreign key dependencies of those tables. You need to understand if there's an access or an authorization constraint on that table. So all of these things become the acceptance criteria for that story. We had to define all this stuff, all these dependencies before somebody would start working on that story. That really helped us because then during our sprint, we were not doing investigative work to figure out what needed to be done. We also, during this pre-alignment and work, we also were getting ready to negotiate. So with our product owner and with the team itself, if we thought that we can do, say, 20 story points in a sprint, we would actually plan for more than that. We would actually write the acceptance criteria and meet the acceptance criteria for more than 20. Because a lot of times when you start talking to your internal team, you realize that you really haven't defined everything that's needed for that story to be done. And that is when you need to have other plan B that you should be able to negotiate with them. Also, an important thing that we did during these pre-meetings was to have every lead involved. So the development lead, the test lead, and we also had a UX designer on our team, which was a very cool aspect of this project, and I will talk about it a little bit later. He was also involved. So all of us were in this room just looking through the backlog before sprint planning, making sure everybody is satisfied with what's on there. So now we start moving. We have this nice backlog. Everything is prioritized. We are really working. We are nailing it. We have all these stories that we're crunching. We're really getting towards our development. but everything is almost done. And this was an interesting phase. And I remember having these arguments, especially as a tester with my development team and with the development lead, where I would go and say, well, but you know, you finished doing that, but I didn't really test it. And the developer would go, well, you wrote the test cases, right? I'm like, yes, I did write the test cases because we need to write the test cases. We have to document this, remember? And the developer would be like, yeah. Let's run the test cases next sprint. Let's just go ahead and demo this. And we would go ahead and demo it. The next sprint, I would go and I would test it because I would be really concerned that nothing got tested. So I would go ahead and test it, but I would not write anything. And so now what would happen is I have tested it, I have developed it, but I don't have any of my compliance needs met. Nothing is written down. So if I leave the company today, can somebody reproduce that result tomorrow? No, they cannot. So we really had to start thinking as a team about what are we really shipping here? Are we shipping just requirements? Are we shipping code? Are we shipping test documents? Are we shipping bulks of documents? Or are we shipping what are we shipping? We didn't really have a good answer to that question. And it was quite interesting because we really thought that we were getting a lot done. And it was not only just us, our product owner thought we were getting a lot of this done. When we would go into our demos, people would actually see this fully functional software, everything's working smoothly because everything is almost done. And so there's this lack of communication because they're not really working on the sprint. They're not really working on the nitty gritty of the product. They really thought that everything is done from testing perspective, from documentation perspective, from all of these aspects, right? However, that was not the case. So we come to the situation where we were doing demos, which were based on happy flow scenarios. We were kind of faking it in some sense. We were doing stand-ups, which would evolve into these design meetings where everybody is kind of discussing what the design should be or what the problem it is. We were doing retrospectives, but we never went back and looked at our retrospectives. We never went back and checked what were the problems that were being faced by the teams. We had either too much on the sprint or too less on the sprint. So we would either get all of it done, or we thought we were getting all of it done, or we would have just too much and we would just keep marking it done because it looks really nice when your burn down chart is pretty, right? So after going through this a couple of iterations, I would say at least 10 to 12 sprints, we now had to come back to acknowledging the elephant. We had to come back and acknowledge the work that really needed to be done by this team at a team level, not just from software building perspective, but again, going back from customer needs perspective, from the product perspective, from compliance perspective. And so we had to start thinking about acceptance criteria around coding, around quality, around documentation. We had to start thinking about all that. So the next transition was we had to account for everything. But then in addition to that, we were already accounting for everything a lot, but we really had to start considering all of these aspects as our definition of done. And we started building our definition of done in this sense. So we got the team really involved. So when we defined acceptance criteria for a development story, so even if we had a development story that had nothing to do with testing, the tester would be involved. The tester would sit with there and discuss the entire aspect of it. How did this help? This helped because the tester could point out a lot of situations that the developers had not thought through. And you would think this is pretty obvious, but a lot of teams don't really practice this. Um, it also meant raising concerns around automation. So say, for example, we had automated our test cases, but in order to automate, you need to really build be the support for automation in your HTML. If needs to have specific XPaths, or if your HTML needs to have IDs, you really need to build that in, right? Or you're going to build it and then the tester is going to come back and say, hey, I can't really automate it because you don't have this, and then the developer is going to go back and make those changes. Or for manual test cases, for example, you wouldn't have that sync around when the developer is going to finish. Is the developer giving the test team enough time to actually run the manual test cases and write them, right? So we had to start thinking about all of this. We also had to start thinking about whatever we were developing, should we automate that or not? And if we're going to automate that, what is the best strategy to automate this? And this is where we really leveraged our UX workflow. So we had a UX designer on the team. So this person was really responsible for designing the entire user interface for the software, but then also this person would go meet with internal and external customers and come up with what in the UX world is called user personas. So for example, in a forensics lab, you can have a technician that's working on the software, and then you can have a lab director that kind of manages the software. And these two people would use your product in two very different ways. So this specific individual was responsible for creating these user personas and really defining the workflow, or how your software navigation is going to work, how your software is going to behave when you go from one screen to the other. Does it even make sense to have some information on, like, when you go from screen A to screen B, does it even make sense to have that information there? So this person worked on all this. So we really leveraged this information in our testing. We used these user personas to identify end-to-end automation paths that would be useful for automation, because they would be the most used workflows within the application. And this was really going and thinking outside the box in some sense, because you don't usually talk to other team members who may not be testers. And this was really an awakening call for me myself to leverage internal resources and work that other team members are doing to help build your test suite or test setup in some sense. These UX workflows and these personas also, from regulatory standpoint, also this was some level of validation for us. So when we had automated testing end to end on these user workflows, we were really validating the software when those features were complete. We were actually making sure that when we give this to an external user, from a user acceptance test perspective, we are able to uh, ship what we said we will. Okay, so coming back to compliance, while we were doing all this, and especially for the test team, every time we would go back and start to look into what is the level of documentation that we need to provide? What is the level of test cases that I need to write? Do I need to do risk management? Do I need to do tool validation? When all these questions were coming up, we would talk to internal quality personnel or other team members who had worked in regulated environment before. And these were some common phrases that came up. Well, I've never done Agile. I don't really know how FDA treats that. Why don't you just work with, like, what everybody else does? Why do you really want to do this new thing? And one of the most interesting things I've heard actually in the field is that FDA or this XYZ authority or regulatory body doesn't allow Agile. And that's not true. Every regulatory body, at least the ones that I have come across, especially the FDA, acknowledges the fact that Agile is a more practical way of developing software. And I quote this. I'm not going to read this, but just for your reference, in 21 CFR 82030, it actually has a concurrent engineering section where it talks about agile methodologies. We also heard things like, you can't really document like that. And this is specifically coming from the perspective of writing a big test plan, which is in some sense, copy pasted from a previous version, or is just a standard template that everybody in the company uses, and just having it for reference, updating it only when you are right about to start your verification, right? That's not really being agile. That's just adding more paperwork to your team, and actually producing all these other documents, right? Uh, FDA does talk about least burdensome approach, and I really like that fact. And so how do you leverage, how do you really get all this stuff done in addition to your software development when you are doing Agile? So the answer is you have to optimize. It is not out of the box. It's not an out of the box solution. You really have to optimize your infrastructure. You really have to optimize the way you work. We used Jira. A lot of teams used Jama, and everybody else used different products to do this. But we used Jira, and I will talk very specifically about this one approach that we took. So our features, any feature that we build in the product was called initiative. You can call it an initiative or a feature. And these were specifically broken down into epics. These were like big chunks, right? And then the epics were broken down into stories and then subtasks. Now, as I spoke before, during our sprint planning meeting, these would just not be placeholders. These would actually contain information. So an epic, say for example, would be building a database that has these 10 tables to provide this feature to the customer. It would not be build a database. It would have all that design detail. Then when you break that epic into subtasks, you would talk about each table. Each subtask could contain requirements. Each subtask could contain design information. Each subtask could contain the testing need. You would start talking about test data. And then once you start testing, you would have test cases that would link to these subtasks. You would have bugs that you get reported would get linked to these subtasks. So you would have like a really nice trace of how development was actually happening. And at least for me, I really call it as a living document. These were not Word documents or Excel. This was really just your simple springboards that had all this information. You were really documenting as you went, and you could very easily export this information using a simple JQL query or another query, but we had to optimize our workflows within Jira to get here. The balance. So this is really where everything came together. So for all of these individual epics, subtasks, tasks, items, we had to clarify as much as you can when you are doing the work. You had to write the acceptance criteria. You really had to define the definition of done. You really had to define the amount of testing that's going to get done, the level of documentation that's going to done. And this was really a hard mark for the team. So if the testing was not completed, that feature would not be demoed. And this really provided visibility, not just to the developers and the features, but also to the test team. And then at that stage, when we said that something is done, it really meant something is done. And if we had changes on that feature, it would be much easier to accommodate those changes versus when it's half done and you're trying to accommodate changes, right? Uh, we also started accounting for defects. So every time we would have a high severity defect, if it wasn't closed, we wouldn't consider that feature done. Documents, data was really critical for us because this was a medical. This is in the field that I mentioned, forensics. Data was crucial to test it for different data sets, for different type of genomes, for all that kind of stuff. And it came down to sharing the work. So we got to a point where we had 2 days left on the sprint, and then automation was not getting done because we didn't have all the HTML IDs in place. Well, the tester can actually write those. Why can't they write it? So the tester started doing some development work. I wouldn't say all of it, but a good amount of development work. And when we really needed it, the developers are actually started executing the manual test cases or even the automation test cases to help. And the reason they were able to do that was because they were documented and they were linked correctly to the stories, and there was a trace that they could follow. Also, we had to make sure that we were in alignment with our internal business needs and quality assurance representatives from compliance perspective, and also any other integration aspects of the application. So if another team within the project needed to integrate with the software, we had to account for all these activities. That was the real balance. This is this was very important. We started to do great on our team. Software was doing great. And then we started doing, like I mentioned, some UAT tests very early on. This was even before beta. So we would have like internal customers doing some sort of validation and making sure that they are seeing all the features. And this is what we saw. We really saw that we had this nice road designed for them, but they weren't really doing that. They were taking the shortcut. And this really helped us define our product better and really prioritize our backlog, and sprint through faster, because we started to see trends of how users actually used the software, and having doing it in a more iterative pattern. When we actually shipped, I personally think that the software had eliminated a lot of workflows, a lot of screens, a lot of data that the user didn't really care about. So a quick recap of all of this. You have to refine and define your backlog. You have to involve everybody early, including your customers. And when I say customers, I mean not just external, but also internal customers. Have a definition of done and acceptance criteria for everything, for your epics, for your features, for your tasks, for your subtasks. You need to have standards and needs. So everybody on the team should be at the same level. Everybody should understand what goes in the demo. Everybody should understand what a retrospective means. What is the purpose of a retrospective? If you don't understand, there's no point of doing these Scrum activities if you're not going to utilize them. Get the team involved. So everybody can help other team members. Developers can help testers, testers can help developers, so on and so forth. Get feedback from your team. So as a test lead, work with your team to get feedback, see what's not working. Somebody's going to come to you and say, well, I don't really get enough time to test. Really acknowledge that and see how you can improve your process. The most important thing is optimize your tools. Nobody in today's world now, uses just Word documents. Everybody uses other tools, so optimize them for your purposes. And the most important thing is quality always comes over quantity. So first, consider testing your products, but then also make sure that what you are documenting and the artifacts that you're creating out of your sprint are actually worth it. And this is where I come back to Scrum and FDA in some sense. So this is a very brief uh, description of how Scrum activities would translate into that nice design control process that FDA has. So for example, product planning, and sprint retrospectives can be considered as design and development planning phase. Product backlog, sprint backlog can be considered as design inputs. Acceptance criteria and designs can be considered as design outputs. Your test artifacts, all of your integration testing, your user workflows are design outputs. You do code reviews and you do design reviews. And these could be part of your sprint demo, or they can even be part of your daily activity. These should be tasks on your sprint board when you do them. These should all translate into design reviews. Your sprint reviews and demos should also translate into design reviews. When you get customer feedback, complaints, any maintenance, internal or external, these should all be tracked, and these all convert into design changes. And all of this coming together at multiple iterations translates into a final software release. So at the end of this whole process, we had a streamlined team interaction. We knew what we needed to do. We had a build as you go strategy. And what this really let us do was we had all our artifacts in place. It was a simple export at the end of the day, or a couple of days to come up with a formal document that would contain all this information, because you have all the information already. It was probably just doing some formatting on it. It really allowed us to ship in 1 or 2 hardening sprints, which is not that much. We had an API automation which ran end to end. It really tested the most validation aspects of the application. We had manual testing. The testing there covered aspects that could be run by anybody. It was written in a fashion that a developer could execute that test. We had reproducibility. We accounted for reproducibility between environments. And after going through this entire process, we realized that internally at Illumina, the quality standards were so high, we didn't even need to meet a lot of those things to develop a forensic product. So we had to go back to them and say, hey, by the way, you really need to start thinking about this from a more diverse perspective, and not just stick with one set of rules and regulations, and really think for each product what they really need to do in order to achieve it. If I'm going to do a risk management, which is important, but there are aspects of risk management that don't really apply to forensics, then I shouldn't do it. Final learnings. So define your compliance. Really look at everything that you need to comply with and narrow it down to what really needs to get done. Define your agile, define the methodology that you're going to take and everything that you're going to do. Customize and expand your infrastructure. This is probably the most important. No tool is going to work out of the box. So you have to really think what you want out of that tool. Is that the right tool for you to use, and how you can optimize it to convert your everyday sprint artifacts into final documentation. Keep your customers at heart. Get your testers involved early to catch on these problems. Identify partners which are outside the test group to help you test. Account for all team deliverables, including product, project, test, and also account for any senior management business needs. I like to really thank my family, which is just my husband, and the team that I work with for this experience and everything else. And now I'll take any questions.
Thank you, Aprajita, for the brilliant presentation. I really enjoyed it a lot. And we do have a few questions, and I'm going
Sure.
to run them through. Yeah. All right. So the first question is about what software can we use to get the agile flow correctly done? If there's any generic software that you use that you would like to share.
We used a couple of softwares. If you are already using a software and you haven't seen the impact of it, I would say go back to post-it notes and really see what you do. So you might be using a project, say for example in Jira, that's been set up for a specific type of workflow. So defects go from one stage to the other, but your team may not really be doing it that way. So I think the core of the problem is not the software that you use, but really identifying what your team does to achieve that task. And the easiest way to do that is really just go to the post-it notes and observe it over 2 sprints and see how you guys use that information, and then try and implement what you are actually doing on physical land on your software. And I think every software should be able to, pretty much all software should be able to support that.
Okay, thank you. The next question is, security is key in compliance sensitive work. While, with agile approach, when does security really step in, especially when you're saying that the complete design is not ready and we are incrementally working on it? So when should security step in there?
Security should step in as you are developing. So as you can see from this chart, right, what I was trying to say from this is really risk assessment and management starts at your product backlog, really, session. So when you start grooming your backlog, when you start working on your features, when you start thinking about something. So if you're working on designing your let's say I'll go back to the same example. If you're starting to design your database, don't just think about the tables, don't just think about the data structure, start thinking about security right then and there. Think about everything that your software team needs to do in order to make it secure to the level that you need it to be secured, right? So it really starts at that level. And then building on your product backlog, you will break it down further into your epics and stories and really start seeing your bigger security aspects broken down into smaller modules. Consider security from authentication perspective, like from an administrator perspective, from a person who is a regular user, from a person who's coming into the lab for the very first time. All of these aspects would start showing up in your everyday feature work.
Any tools that you have used or would suggest for this?
For cybersecurity or just security in general?
Yeah, just for the compliance work security, like specifically in this project.
No, so no specific tools. This was all tested in-house in some sense.
Mm.
Yeah.
Okay. So the next question is, what kind of stakeholder communication did you have to do for agile buy-in at your organization? Mostly managements could be wary of doing so, especially for compliance heavy projects.
Yeah, and that was one of the things that I brought up, right? Like FDA doesn't allow it. Why don't you just do it? I think at the end of the day, you have to show senior management that it's worth to. There's a return on investment in doing this, right? So, what you can do is start with a small feature. Don't If you don't do Agile currently, talk to your development team and work on a single feature and show the progression that you have made on that single feature and use that as a model and take it to your senior management and say, hey, by the way, notice that when we started doing sprint planning for this, I knew exactly what to do. I see I have all of this already documented. It's really easy for me to do this. So you'll really have to go back to them from a business standpoint and say that there is a return on investment, uh, you know, using this methodology.
Hmm. Thank you. Okay, here is one which says, uh, so as you've moved from waterfall to agile, now do you see your kind of work move to DevOps at some stage?
We already use DevOps. This project specifically didn't use DevOps because of the user constraints, but we already use DevOps. So yes, absolutely.
Mhm. Okay, and one last question here. Uh, how would you apply these agile practices in instrument testing or very specifically healthcare testing, for example, where you do IQ or QPQ kind of thing?
Yes.
Yeah.
So that's a very good question. So IQ, OQ, PQ basically translates into making sure that your software is installed correctly, it's operational, and its performance, right? And if you think about it from a testing perspective, operational readiness can be tested using both verification and validation, which you are doing, like in your sprints, you would be doing according to this chart, as you can see. You will be doing that using both your system level test and your integration test, right? And you always have to do some level of validation, right? So you should be able to do PQ at that when you're ready to ship. You should be able to do it then. Installation would really depend on how frequently you're releasing. So if you're releasing the software internally to customers, then that is a great opportunity to test it. And that's why I kept talking about internal customers and leveraging this. So then you have timestamps within your product development where you have done IQ not just once, but actually multiple times. Every time you deploy your software, which is being used by internal customers that are giving you feedback, that you did an IQ, you did an OQ, and you are doing PQ as you are developing it. So it all kind of comes together when you think about it from a holistic standpoint.
Hmm. Thank you. That should be all for now, Aprajita. Thank you so much. It was a very insightful session on how we could actually make our compliance testing work more agile. And also, I personally enjoyed all the background details you set up for genomics. I've always wanted to learn more about that. Uh,
Thanks, Mita. Thank you so much for having me. I look forward to any other questions you have and to answer them.
yeah, I'm sure our attendees found it very useful. And thank you so much, Aprajita, and I hope to see you in Virginia.
See you. Bye.
All right. So thank you, everyone. This concludes our webinar for today. Thank you for joining. And if you want to see more such sessions from speakers like Aprajita and others, please do come over to STPCon Fall 2018. And stay tuned for more webinars and online trainings coming soon at SoftwareTestPro.com. And if you haven't signed up yet for the upcoming webinar, which is The Art and Science of Test Automation by Mandana Nabizadeh on 10th October, then please do. Mandana is the Principal Test Automation Engineer at Discount Tire Company. The link is up for you to review and register. Go ahead. Thank you, everyone. Have a great week ahead. See you all in Virginia in October 2018. Happy learning always.